Hi, I built a falling sand simulation in C++ using SFML. It allows me to place different particles like sand, water, fire and more, and watch them interact in real time. From fluids flowing and fire spreading to acid corroding wood and stone, some really interesting behaviors emerge from a few simple rules. Let's take a look at how it works. First, let's look at how the simulation itself works. Sand is one of the simplest particles to simulate because it follows a small set of rules. When updating a sand particle, we check the cell directly below it. If the cell beneath it is empty, the particle moves down. If it's blocked, we check the down left and down right cells. If one of those is empty, the sand falls diagonally. If all possible positions are occupied, the particle just stays where it is. Even with this simple rule, sand starts behaving in a very natural way. To implement this behavior, I use a grid of particles with a fixed width and height. Each frame I iterate through the grid and apply the update rules to every particle. To make sure a particle isn't updated more than once per frame, each particle stores a boolean flag indicating whether it has already been processed. After each frame, all flags are reset. The grid is also iterated from bottom to top, which allows particles to fall naturally and prevents artifacts where sand appears to float or move inconsistently. With the simulation logic in place, we can already see sand falling and piling up nicely. However, performance quickly becomes an issue. The problem lies in how the particles are drawn. Right now, each particle is rendered as its own rectangle shape, which means one draw call per particle. With a 100 by 100 grid, that's 10,000 draw calls every frame. At 60 frames per second, this results in 600,000 draw calls per second, which is far from ideal. To fix this, I switched to using a vertex array. A vertex array stores large amounts of geometry data and can be rendered with a single draw call. Each particle is represented by two triangles, and the vertex colors are set to match the particle's color. After filling the vertex array, the entire grid can be rendered in one draw call to the GPU. This change drastically improves performance and allows the simulation to scale much better. Next, I added water to the simulation. Water behaves similarly to sand, but with a key difference. It can also move sideways when blocked from falling down. Sand is heavier than water, so when sand falls onto water, the two particles swap positions. This allows sand to sink while water rises, creating more realistic interactions between the two materials. At this point, the simulation looks much more interesting, but we also need particles that aren't affected by gravity. For that, I added solid particles like wood and stone. These particles don't move at all, but they serve as obstacles and building materials. Wood has one important difference though: it can burn. To add fire, I created a particle that can move freely in all directions. Fire also has the ability to spread by igniting nearby flammable particles. Each particle has a flammability value that determines how easily it can catch on fire. When fire is adjacent to a flammable particle, there's a random chance that it ignites and turns into another fire particle. This allows fire to spread naturally through materials like wood. To be able to set a world on fire, we also need oil. Oil behaves similarly to water but has a much higher flammability than wood. It's also lighter than water, so it floats on top. I also added steam particles, which are created when water comes into contact with fire. Steam rises upwards and behaves like a liquid but in the opposite direction. Over time, there's a small chance that steam condenses back into water, creating a simple rain effect. Finally, I added two of the most destructive particles, acid and lava. Acid behaves like a liquid but has a chance to corrode and destroy nearby particles. More durable materials like stone have a lower chance of being destroyed, while weaker materials like wood are more easily affected. It's also very flammable, but not as much as oil. Lava combines the movement of a liquid with the destructive properties of fire. It can burn other particles, and when it comes to contact with water, it cools down and turns into stone, just like a real Minecraft cobblestone generator. With all these particles in place, we can start experimenting with them and see what kinds of simulations we can create. I really enjoyed creating this simulation, and if you have any ideas on which project I should create next, no matter how crazy it is, leave them down below in the comments. This is just my first project from many to come, and I would appreciate if you like the video and subscribe to my channel, so you don't miss the next video. See you until then.